Okay, and the second one is area of a sector. So if you've got sector, angle, theta, radius r. If you were working in degrees, you would have done this at school, and you would do theta over 360 degrees, so you have that fraction of the whole circle times by the area of the circle, which is pi r squared. So we can do exactly the same thing, except we're working in radians. So the area is theta over 2 pi times pi r squared. The pi's are cancelling off, and so the area is equal to a half r squared theta. It's a little bit tidying up and rearranging. So that takes you to there. So as an example, you could have a sector of radius 2.44 and angle 1.4 radians. This doesn't work. If this angle was in degrees, you would get the wrong answer. So the angle has to be in radians, and the area is equal to a half times 2.44 squared times theta, which is 1.4. So you don't convert it to degrees or anything, just like with the arc length, you just put it in radians, and you end up with 4.17 centimetres squared. You can just put that into your calculator at that point there. So that should be quite straightforward, and then obviously given the area and an angle, you can get to the radius and so on. So that's area of a sector. So I'm teaching off the cuff a little bit because I don't have any notes for this. You also need to be okay with finding area of a segment, and you do know how to do this, but I'll go through an example with you. It's just putting the nuts and bolts together. I'll see there's an example here I can use. I could be really lazy. Hang on. Yeah, so that's quite a nice one. So if you have, for instance, sector. So this is length 4, and then this length here is 5, and that is a segment of a circle. So you should have all your terminology okay now. So you've got a chord going straight across, sector, a segment. It looks like a segment, doesn't it? And we can find the area of the shaded segment. So for this one, there's a little bit going on with this. I need to find this angle here first. So you might need to bring in your cosine rule and your sine rule into these questions as well. So it's just pulling in all those bits of trig that we've done already. So opposite angle squared, so using the cosine rule, because we have all three sides and we want an angle. So the opposite squared is equal to, and then it's two sides, and the included angle on the right hand side. So it's 4 squared plus 4 squared minus 2 times 4 times 4 times cos theta. So it's a squared plus b squared minus 2ab cos c. Rearranging that to get cos theta. So I'm going to take this over here and do 4 squared plus 4 squared minus 5 squared divided by 2 times 4 times 4, and that gives you 7 over 32. And then you need to be careful because you want this angle in radians. So when you do shift cos of 7 over 32, you need to put your calculator in radians mode. I'm going to probably say that more than once actually, but please remember that you need an angle in radians. If you have your calculator in degrees mode, it will give you an angle in degrees. And so theta is 1.3502. I would sort of store that to x, so you've got it nice and safe. You don't want to sort of get a rounding error as you go through the question. And then continuing on, we can now find the area of the segment. So the area of the whole sector is equal to a half r squared theta. So it's a half times 4 squared times 1.3502. But again, use your answer button or something like that. So that's the area of this whole sector. And to get to the area of the shaded segment, I need to take away the area of this triangle. And we've got two sides, included angles, so that's a half AB sine of the included angle. And the included angle is 1.3502. So you could sort of pull out a half times 4 squared as a factor of both if you want to. Sort of turn it into a formula, but you don't need to. So area of segment is equal to a half times 4 squared times 1.3502. So that's the area of the sector minus the area of the triangle. So it's a half times 4 squared times sine of 1.3502. And you can just pop that through calculator, and you should end up to 3 significant figures with 3.00 units squared for that one. But yeah, just be a little bit careful, rounding error from there. But you're basically just doing the area of the sector minus the area of the triangle.